Hello everyone, in this video I will walk you through how I improved a load before prediction classifier for the M4 practice hackathon with my classmates. I will explain the virtual energy techniques, how I handle class imbalance and the different model I test. Finally, I will discuss model evaluation and overfitting prevention. The goal of its challenge was to predict whether a load application would default or not, based on their financial and demographic data. Since the database was imbalanced, optimizing for M1 score was brought to ensure both precision and recall were balanced. To improve my model's performance, I focused on three key areas: virtual energy, model selection, and class imbalance handling. First one, a virtual energy creating meaningful predictors. I transformed the data set by adding features that provided deeper insights into an applicate's financial behavior. Some of the most impactful ones were debt to income ratio. This helps assess an applicant's ability to repay their loan. The second one is risk score, a feature combining interest rate, loan size, and the credit score to measure financial risk. And the last one is income per credit year. It divides the applicant's annual income by their credit history length, giving an indication of financial stability. This new feature helped separate defaults from non-defaulters more efficiently, improving model accuracy. Second, comparing multiple models. I tested three different models with my friends to find the best balance of performance and interpretability. The first one is Light GBM. This model was the best overall. It was fast, handled missing values well, and performed the best on the imbalanced dataset. And the second one is XG Boost. While very powerful, but it required more turning and was slightly slower than Light GBM. The last one is Cat Boost. Great for categorical data, but its training times was higher and the performance was slightly behind the Light GBM. After after evaluating them, after evaluating them, we selected Light GBM as the final model because it has the highest F1 score and the best generalization ability. Second part is about our handling class imbalance. Since the database had more non-defaulters than defaulters, I need to make sure the model didn't just predict non-faults all the time. We used the three approaches. First one is SMOTE to balance the database. The second one is adjusting class weights so the model paid more attention to the defaulters. The last one is threshold turning to ensure the probability of correctly capture risky applicants. Next part is validation strategy about ensuring stable performance. We used a five-fold streamlined cross-validation instead of just a single train test split. This helped ensure my model performed well across different subsets of the data and prevented overfitting to a particular split. The next one, we plotted a learning curve to check if the model was overfitting. If the training accuracy was much higher than validation accuracy, that would indicate overfitting. To fix this, I used earning stopping, so the model stopped the training when performance stopped improving, and regulate and regularization techniques like limiting the number of leaves in light GBM to reduce complexity. And for confusion matrix and precision recall curve, we used a confusion matrix to understand false positives and false negatives in a low approval setting, like a false positive means proving a low debt will default, leading to financial losses, and like a false negative means rejecting a loan that wouldn't have defaulted, missing out on potential business. We also plotted a precision recall curve to find the best threshold for load approvals, balancing risk with business profitability. In summary, we improved the model by applying advanced feature energy, using light GBM with hyperparameter tuning, and handling class imbalance efficiently. We validated approach used cross-validation, confusion matrix, and the learning curves to ensure a well-fitted model. It gives more time. We would integrate more external data source and deploy the model with real-world monitoring. That's all. Thanks for your watching.